Time for My Boat.
This week on My Boat, we're going to guide you through the steps of repowering your outboard boat. Often the question arises of why it still runs, and in the case of our project boat, that's true. So before we get started, let's take a look at how this old 1980s technology stacks up and the reasons for replacing it. To do this, we traveled to Sandy Cove Marine to run the engine on a marine dyno to record power output and fuel consumption. What we discovered in testing was an old motor that was extremely hard to start and idled poorly, burning 1.2 gallons per hour, and consumed 5.5 gallons per hour at cruise settings. Under full load at 5,000 RPM, we were enveloped in a cloud of exhaust as the engine burned through 9 gallons per hour of 50-to-1 mix. Definitely a polluting fuel burner that had seen better days. Back at our shop, I got busy de-rigging the old engine. I started by disconnecting the fuel, then the battery leads and the electrical harness, and removing all of the wiring from the engine. The next steps were to disconnect the steering arm and then the shift and throttle cables. Once these were done, the steering cable was disconnected from the motor. With an engine hoist in place to carry the weight, the 4 bolts holding the engine to the transom were removed and the engine lifted off. Finally, all of the cables, engine wiring harness, and shifter were removed from our project boat. The final prep was to fill the holes in the transom with a waterproof marine filler. We've accomplished the easy task of removing our old motor, stripping out the rigging, and filling the holes in the transom. Now it's time to move on to the more complex task of installing the new outboard motor after carefully reading the instructions. Using a special lifting eye that threads on the end of the crankshaft, the motor is lifted to a horizontal position and the shipping pallet is removed, saving the bolts to mount the motor. Next, remove the shipping plate from the engine transom assembly to free up the steering and tilt. Prior to starting to mount the engine, apply some 2,4-C lube to the tube for the steering mechanism. As you move the motor into place on the engine hoist, carefully guide the steering cable end rod into place and hand tighten the nut on the assembly. At this point, you can slowly begin moving the engine into place and begin to position it on the transom. Installing a motor, properly centered and vertical, is critical for handling and safety. Make sure you measure more than once. The height of the motor, or X dimension, will greatly affect the boat's performance, so ensure that the mounting height and the position of the cavitation plate from the bottom of the hull fall within the manufacturer's specs. When properly positioned, drill the top 2 holes in the transom. To ensure no water penetrates the transom, use plenty of sealant such as 4200 on the bolt shafts and install the bolts and washers. After inserting the bolts, apply more sealant on the outside and thread on the washer and nut and secure both bolts. Then repeat the process for the 2 lower bolts. With the engine mounted, next connect the steering to the steering rod on the motor. After removing the lower cover section, the battery leads and fuel line are pulled through from the engine to the boat. Next, the new wiring harness is laid in place down the gunnel and fed through under the deck and into the transom well. Route the harness into the motor and simply plug it into the socket on the motor. With the engine mounted and the steering connected, the next thing we're going to do is move on to the rigging of the boat. And the first task is to install the shift throttle control and the cables back to the motor. The first task is to tape the template to the side panel in the correct position, then cut away the vinyl upholstery. Then using a jigsaw, trim the opening to shape. Finally, cut additional holes with a hole saw and pre-drill the bolt holes. With the cutout completed, next install the control faceplate in position. Next, feed both the throttle and shift cable into the boat and along the gunnel to the shifter. Remove the cover on the control box and, referring to the installation manual, make sure that the shift and throttle cables are connected to the right points, since this differs by engine. After replacing the cover, the control unit is positioned behind the side panel and bolted to the faceplate. Snap the cover into place and feed the wires for the trim through the opening. After lubing the plastic bushing, slide the handle onto the spline and bolt it in place. With the shifter installed, shift into gear and push the throttle forward to determine the throttle cable and mark it. First, install the shift cable by removing the nut on the shift linkage and snapping open the cable retaining clip. Adjust the retaining barrel on the cable and slide the cable into the engine. Next, slide the end onto the bolt on the linkage and position the barrel in the cable mount. Install the nut and test the shift lever and cable movement. Repeat the process to connect the throttle cable to the throttle linkage, sliding the end of the cable over the bolt, then securing the cable retaining clip over the barrels, and then tighten down the nut. With everything hooked up, replace the lower covers, wrap the cables, wires, and lines in the supplied neoprene, and secure with tie wraps. Moving to the helm, you will note that our project boat had a full set of analog gauges, but I elected to install an all-in-one SmartCraft digital instrument in place of the trim gauge. Finally, I installed a new ignition switch in preparation for the wiring harness. The wiring harness for Mercury was truly plug and play. All I had to do was plug in the trim control, neutral start wires, and safety lanyard lines, then crawl under the helm and plug in the SmartCraft gauge and the ignition. It took longer to neaten up the wiring with tie wraps. Now that we've taken you through the steps of how to rig a brand new outboard, we're going to head back to Sandy Cove Marine and see how this new Optimax compares against that old 1980s technology. With the dyno and water hooked up to the new Merc, the technicians used a computer to check for faults and then prime the oil injector pump. Unlike the old engine, right out of the crate, the Optimax fired right up and settled into a quiet, smoke-free idle. After some warm-up time and diagnostic checks, it was time to spool up the engine under load and take a look at the numbers. The SmartCraft system indicated 0.1 gallons per hour at idle and only 2.4 gallons per hour at cruise, a 50% reduction, with a 3-star emission rating as well. Well, we've seen the numbers, how much more fuel efficient the modern technology is, so you should consider a repower in your future.